Alright, today I'm going to be showing you how to run a paired sample t-test or a dependent sample t-test. I'm using the same data set we covered in the lab. So it is the same example where we have 12 people who have fear of spiders. Their anxiety level is measured in two different conditions. One when they're shown a picture of a spider, and the other when they have a real spider in front of them. Since this is a continuous DV and it has a categorical IV with only two levels, the best approach to analyze this data to compare whether score in one condition differs from the score in the other, we would apply a dependent T or a paired sample T. So how you run it is you go to Analyze, Compare Means, and Paired Sample T-Test. Once you click that, you'll have this window open up. Here, all you have to do is just to put in the variables that you want to compare. So we have picture of spider and the real spider condition. And that's all you're going to do. We're not interested in other options that it's giving us. We are just going to add the variables and hit OK. So here are the bunch of tables that SPSS gives us. The top one is kind of like demographics and overall just a snapshot of the data. So it shows us the means for each condition as well as total number of cases and standard deviation and standard error. It also gives us correlation between the two variables and whether that is significant or not. Paired sample t-test, on the other hand, we will focus on the significance value here, and when you're reporting, you will be reporting the value of t as well, as well as the degrees of freedom. Anyway, so just looking at the significance level, we can see that this comes out to be significant. So our question that whether anxiety level differs for the two experimental conditions that we're looking at, yes. So people who or participants who their anxiety level was significantly different in the two experimental conditions. And when you look at the mean values, you find out that when they had a real spider in front of them, they were more anxious as opposed to when they were shown a picture. Right. So this is all we need for a paired sample T. Now this kind of analysis you can run using repeated measures ANOVA. And it is going to give you exactly the same information, but it will give you a little bit more information as well. So typically you don't run repeated measures ANOVA when you have an IV with only two levels, but I'm just going to show you for demonstration purposes. This time you go to Analyze, and you will go to General Linear Model, and then to Repeated Measures. And this time you need to name the factor or within subject's factor that you have. In this case, we're dealing with spiders, so we can just call that spider. And we know it has two levels or two conditions that we are working with. So we'll put 2 and hit add. And then we will hit define. And here we need to just specify which condition we want SPSS to code as 1 and what condition to be 2. So at this point, it doesn't really matter, but be mindful that the first variable you will enter into this box will be given a code of 1 and the second one given a code of 2. So we just want that. And again, we're not looking into a lot of other information that other options that we can perform. We do need means when we when we look at our analysis, but since we already have the mean values, I'm not going to be interested in that. But if you were to run it the first time and you don't have the mean values, you can go to options and check that descriptive statistics over here. All right, so now I'm just going to hit OK, and then it gives me these 6 tables that has a lot more information that I need. Basically, starting off with, what is the code that I put in. I'm just going to ignore this table. We don't need this for this analysis. Mauchly's test of sphericity. So Mauchly's value looks like perfect. This happens because it is only a 2-level variable, independent variable we're dealing with, so we're not worrying about sphericity, so we will ignore this table. And then we are looking in the table of tests of within subject effect, and we are looking at the row where it says severity assumed, and we're looking at the value of f and the significance level. If you see that significance value is identical to what we had before, and if you look at the value of f, basically it is the value, if you square the value of t, you'll get the value of f, because t squared equals f. And this value here, which is sums of square, this basically shows the sums of square for the experimental conditions, which is SSM, that we talked about in the lab. This is basically the mean sums of square of M, which is MSM. And this is the sums of square for the error, or SSR, and this is the mean sums of square, so related to that. We are, when we're looking at the sums of square values, we're not going to be looking into the table of tests within subjects. The reason is that since this example has only 2 levels within an IB, the values here look identical to what we have here. But once we run an analysis with more levels within an IB, this table would look different. So if you are asked to locate the value of SSM or mean sums of squares, you would always look at the table of tests within subjects effect. And basically, this is it. So this is how you run a paired sample T or dependent T, and how when you run and repeated measures ANOVA with the same database, you would be ending up getting a similar conclusion. All right, hope this is helpful. Thank you.